Hello, welcome to the video. We're looking at section 3.1, where we're looking at pairs of lines and angles. So our essential question that we are going to look at, it says, what does it mean when two lines are parallel, intersecting, um, skewed, or coincident? So if we look at our chart here, it says here, it says work with a partner, and it says write the number of points of intersections of each pair of coplanar lines. So you don't necessarily have to work with a partner, but parallel lines are any types of line where the two lines don't touch. Okay, so if you look here, this is an example of two parallel lines. How can we know that they're two parallel lines? Well, these two arrowheads along the end of the line determine that, or give us a symbol that the lines are in fact parallel. For intersecting lines, we know that they are intersecting because it crosses at a singular point, which is right there. And we know that it is a coincident line because it is a collinear line, which means that points are, um, they show up as, you know, multiple points show up as in a line. So one of the things, actually, where most people get are unsure of is the big difference between parallel lines and skew lines. So parallel lines are two lines that don't intersect and are coplanar. Skew lines also don't intersect, but the big difference is they are not coplanar. So if you look at this diagram to our left, lines M and N are parallel because not only do they not intersect, but they are also coplanar. They're on plane T in this case. Here we're saying that line M and line K are considered to be skew lines. Yes, they don't intersect, but they are in two different planes. So they are not coplanar. Okay. We have other things that we've been able to easily dissect or easily identify where like T and U are parallel planes. Those are planes that don't intersect. Lines K and N are intersecting lines, and that good stuff. So like it says here, it has the small directing arrows that shows that lines are parallel. Okay. So we have our diagram to our right. It looks like, appears to be like a cube, but it's got different points and different line segments to help illustrate it. So here it says, think of each segment in the figure as part of a line. Which line or lines or plane or planes appear to fit the description? So there may be multiple answers to these particular questions. So first it says line or lines parallel to CD and containing point A. So point A is right here. So everything that is parallel to CD, so CD is right here, well, line AB, that's parallel. You could also say HG can be parallel, all right? The plane would look something kind of like this. Okay, even though it doesn't identify it as a plane, that plane is actually there. Um, Other ones would be like line EF, and I think that's it. But, oh, the ones that contain point A, the only one that contains point A would be AB. Here they're looking for skew lines, CD and containing point A. So ones that are considered to be like skew lines would be like AH, AG, um, like BG would be a skew line. But again, the ones that contain point A are AH and AG. So here, lines that are perpendicular to CD but contain point A, I would say it looks like AD. I'll just the ones that contain point A, and then I think that's it. And then D would be planes parallel to EFG. So that's this one right here. So you could name it however you'd want to name it. So we could just say that let's see here, EFG. So we could say like ABC. So it'd be no, actually, I'm sorry. It'd be this plane right here. So plane ABC would be parallel. So it'd be this one right there. All right, so here it says, look at the diagram in example 1. Name the line or lines through point F that appear skewed to EH. So EH is right here, and you got to use point F, so I would say CF would work. Let's see if there's anything else that would work. CB would be parallel. Maybe we can go CD. Yeah. Here we have two postulates. One is a parallel postulate. The conditional statement says if there is a line and a point not on a line, then there's exactly one line through the point parallel to the given line. There's exactly one line through P parallel to L. And so they kind of drew it there. Next is the perpendicular postulate. It's the same idea. It says if there is a line and a point not on a line, then there's exactly one point through point perpendicular to the given line. There's exactly one line through P perpendicular to L. So you could say that whatever point P, there's one particular line that's perpendicular and also parallel. So here it says given line markings show how the roads in a town are related to one another. So it's asking you to name a pair of parallel lines. So in this particular example, you can only basically you can only show what is given to us. So we can say that in this particular one, that let's say probably what, MD is parallel to EF. Because of these two hash marks representing that they are in fact parallel. Are other ones parallel? Maybe, but again, we can't make assumptions on that. And then it says name a pair of perpendicular lines. Well, this one here with the 90 degree, I can now say that AB is perpendicular to AD. Oh, no, that's not. So it'd be MD, I'm sorry. MD is perpendicular to MB. My bad. A is right here. That's M. My apologies. Here it says, is FE parallel to AC? And the answer is no. Your explanation would be that because MD is parallel to FE, and by the parallel postulate, there is exactly one line parallel and it's already been taken. So that's what your explanation would be. Here we have some angle relationships. Some of this is review. Um, you can find these different angle relationships on page 128 in your text. But again, if you have a transversal like line T and you have angles that are in like the relatively same position, so like angle 2 is upper right, angle 6 is upper right, those are corresponding. If you look inside the transversals and you have alternating interior angles, so like 4 and 5 are considered to be alternate interior angles. Same idea, you have alternating exterior angles like 1 and 8, and then finally you have consecutive interior angles like 3 and 5. So here it's asking you to identify all pairs of angles of given types. So this is our transversal right here. So let's call it like that line T. So we could say that angles 1 and 5 correspond. We can say that angles 2 and 6 correspond. We could say angles 3 and 7, and finally it's angles 4 and angle 8 correspond. Our alternating interior angles are angles 2 and angle 7, also angle 4 and angle 5. Alternating exterior in this case would be angles 1 and angle 8, and angles 3 and angle 6. Finally, consecutive interior angles would be angles 2 and angle 5, and then finally angle 4 and angle 7. Here, they're asking us to classify the pair of numbered angles. So 1 and 5, they're both upper left. Those are corresponding. 2 and 7 are on the outside, so they're alternating exterior angles. And number 5, 4, and 5, they're on the inside. They're alternating, so they're alternating interior angles. And that is to be able to find pairs of lines and angles. Hope this helps. Till next time.